we go. So everybody, the first thing it's going to ask you is, if possible, solve the triangle around to the nearest degree. Now here's the thing, guys. There's a triangle. If a triangle's already drawn, you don't have to use that. You can go off to the side and draw your own. Sometimes it's easiest to draw your own to get the picture in a way that makes it easy to look at. You'll see what I mean. So it says, given these sides, so guys, we're given angle B, so this isn't set up bad. This triangle is set up okay for us. So we'll put our 25 degrees here. Side A is 7.5, right? So this is 7.5. In fact, you know what I want to do? Is I'm going to go like this, just because I really think this is going to help some of you that struggle a little bit. So we're given angle B. I'm going to draw it myself. This is 25 degrees. Side B is, we weren't given side B. We're given, okay, never mind. Angle C is 55 degrees. I'm just going to use this. I thought this was a different problem. And then side A is 7.5. I can't think right now. Is this my picture? Okay. All right, I gotta focus. All right, so now it says solve the triangle if possible. So this is definitely possible because if we're given two angles, we can find the third angle and then use the law of sines, right? So very quickly here, my third angle is gonna be, okay, 100 degrees. And then from there, we'll just set up the law of sines to find either side B or side C. So why not side B? So we would say B over sine of 25 equals 7.5 over sine of 100, right? And then we would also do side C as well. So we would say C over sine of 55 equals 7.5 over sine of 100. And then just use algebra to solve for B and C. So guys, go, type that in. Tell me what's B. Make sure we can all get it. Yep, so let's change colors here. B is 3.2 and C is 6.2. So everybody's good with the algebra on that one. Pretty easy. Okay, next one. We were just like filling it in. So we had 100 degrees as an answer for the angle, and we found the other two sides using the law of sines. And we just went through and did the algebra. 3.2. And then side C was 6.2. And we just did algebra together. Okay. So this is where I like to draw my own triangle just to set it up more prettily to how I can see it better. Does that make sense? Okay, so watching. Here we go. We're given angle B and we're given two sides. So this is one where I like to go off and draw my own kind of triangle and then I can fill it in. So given angle B, so let's put that here, 36. And the reason I like to draw it in like this is because this is how we were picturing it going around. You know what I mean? The other day? Yeah. So side B is 8. Okay, so this is 8 right here. And then our other given side was 18. So I'm going to call this 18. I just like to set it up myself instead of putting it on this because then some people start to get confused. Does that make sense? Then you could go transfer it over if you need it. All right, so let's check. How many triangles is there? Well, it's definitely, this side is definitely shorter than that side, right? But is it longer than the height so it crosses down? Let's check. So the first thing we would do is set up a trig ratio. So we would say sine is opposite over hypotenuse. So sine of 36 equals question mark over 18. So my question mark is 18 sine of 36. Let's figure out what the height is really quick. 10.5. Okay, so that is my height. So is this side ever going to come and be able to cross down here? No, so it's going to swing like this and go back and forth and never create a triangle, right? So on something like this on the test, you'd say no triangle exists. That's a triangle. A fancy one. What? No solution, yeah. No triangle exists. But does everybody understand? Okay, everybody looking at this next example here. How did I do what? Ask me, because other people have the same question. Well, I wanted to find the height, because so we were given an angle and two sides. The angle was across from a given side, right? 8. Now we have to check to see, is 8 is definitely shorter than 18, correct? So if this swung down here, it's going to cross somewhere right here, right? Yeah. Okay, but if it's longer, if A is longer than the height, it will cross down here and cross again, which would be 2 triangles. So we had to check and find the height. So we set up a trig ratio because isn't this a right triangle right here? So we used 36 and we said sine, because why did we choose sine? Because we're doing opposite and hypotenuse. So we said sine of 36 equals height over 18, because that's what it is, opposite over hypotenuse. Then we solve for question mark, or height, which we got the height to be 10.8. So do you see how if 8 swung down, it's going to hit somewhere down here. It's never going to cross 10.8. It's not going to be far enough down.
Okay, so this one,
Yes. Yep, so other people were wondering that same thing. So when this comes, it's swinging down and never crossing. So that makes it no triangle. Okay. Here we go. So looking at this one, given an angle and 2 sides, I like to draw my own triangle because it's harder to see it in a different, you know what I mean, like twisted and turned. So I'm just giving you hints because I can be honest with you about something. Okay. So we're given an angle. I don't like to put it in a triangle already given for me. So angle A is what we're given. It's 62 degrees. Then side A is given, which is 20. Okay, cool. And I'm not going to connect it unless I know it connects. You know, that's why I'm testing this out. And then side B, let's call this side B, and that's 12. So let's see here. Isn't this side A much longer than this side? Yeah. So if we were to draw this more appropriately, it's going to come out more like that, right? And isn't it going to just touch once? Because this is length 20, right? So it's going to touch once, and then it's going to cross and never cross again. So it makes that one exact triangle. So now we can solve that one triangle by using the law of sines. So this is angle what? B, because this was side B, so C. Okay, here we go. So now we will call this side C, and then let's go through and find whatever we want here. Angles, probably, right? Right here, we're going to want to find that angle first. So we would say sine of B over side across from it, which is 12, equals sine of 62 over side across from it, which is 20. So you're going to use algebra to get B alone, so you're going to go ahead and do that. So what we have, do the algebra if you need. Multiply by 12, take the sine inverse, right? So angle B is going to be equal to sine inverse of 12 sine of 62 over 20. I got 32. Okay. 32 degrees. Okay, great. So now we can easily find this angle here. 180 minus 62 minus 32 is 86 degrees. Are we good? And now our last step would be to solve for side C. So we would go ahead and go C over the sine across from it. C over sine of 86 equals, and we could use either or. So I'm just going to go with 20 over sine of 62. And now we're solving for C. So C is going to be 22.6. One thing to check, is your largest angle across from your largest side? Is your smallest angle across from your smallest side? And middle across from middle? If so, you're probably good. If not, though, then you definitely know something went wrong. Okay, good. Questions on that? 22.6. So this is a big portion of the test. It's just going to say, is this triangle acceptable? Okay, I have to change this problem. I changed it on here after I saw it out when I went home. We're going to call this 12. Okay, everybody watching, this one's a good one. So given these angles, once again, I like to draw my own triangle. So we're given an angle and 2 sides again. So let's go up here. We're given angle B, which is 62. We're given side B, which is 12. And we're given side C. So we're calling this side C, so wherever this touches will be angle C. This side C is 13.2. So we're given an angle and 2 sides. So we're going to see if this is going to be able to make a triangle. If so, how many? So we need to calculate the height because we definitely know it's shorter than this length, right? So it's either crossing never, if it's not as long as the height, or it's crossing twice. So let's figure out this height. Drop down a perpendicular line. Let's call that height. Now we have a right triangle. So we'll set up a trig ratio. We'll say sine of 62 equals opposite over hypotenuse. So our height algebraically comes out to be, right, 13.2 sine of 62. Our height is 11.6. So it is longer than the height. Therefore, when this leg comes down, here it is, it's coming down. It's longer than 11.6, so it hits once, right? Yeah. Then it's coming down, 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 hits twice. So we have this triangle, boom, 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 and we have this triangle, boom, 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 right there, right? Okay, so I want you to go off to the side and draw in both of those new triangles. We have one with an obtuse, and that was angle C. So call it C, B, A, label it, 13.2, 62, I should have wrote a little bigger so that's not so squished. And then 12, right? Isn't that length 12? It's just going down this way. I didn't draw that very drawn scale, but it's okay. And we also have this looking triangle where we still have BAC right here. This is still 12 here. This is still 13.2. This is still 62. And then we're golden. So now what you're going to do is you're going to set up the law of sines and solve. And find angle C. I'm getting myself some room here. So we're going to find angle C. So we would say sine of C over 13.2 equals sine of 62 over 12. So C is going to be equal to, if you did the algebra, we're going to get out, and I'll explain why I know I'm doing the acute one in a second. Well, isn't this smaller than 90? And isn't this one larger definitely than 90? Okay, that's acute versus obtuse. Okay, so the math comes out to be sine inverse of 13.2. Is anybody upset that I'm not doing that? Are we pretty good with the algebra there? Like that I'm not doing the steps for that? Are we seeing that? Okay, so angle C is 76.2. So that's the acute one, 76.2. Everybody agree? Now remember that we took the sine inverse, which only gives us output between positive 90 degrees and negative 90 degrees. So that was positive, that's this triangle, right? 76.2. So our obtuse angle is the triangle that's created over here, like that. Does that make sense? So we need this angle. So you'll take 180 minus 76.2. 180 minus 76.2. So angle C on the obtuse triangle is 103.8. Okay. And now we can find angle A very quickly. Over here you'll do 180 minus, sorry, I was just looking to see if I have my work. 180 minus that. What's angle A? And then over here, what's angle A? 180 minus 62 minus 103.8. How did we figure out this angle? We took 180 degrees and we subtracted our acute angle, 76.2 degrees, which gives you 103.8 degrees. So that's our obtuse angle.
Well, that's weird.
That works because this triangle is the acute one and then here's the obtuse one. Yes. Okay, I'll explain that one more time. So Sarah, good question. If this is 12 and this is 11.6, if I took and put this exactly down here, won't it go lower than 11.6? Yeah. Okay, so let's take it out to the right place to make a triangle. So I'm swinging that out. Right there, it's going to make a triangle, right? You see the acute angle now? Like, look, that's an acute angle C. This is side C, right? So this is angle C. But now also we keep swinging it this way, and there it's crossing there, right? It's in a perfect spot, right? Touching perfectly. So now we have this obtuse angle, because see, side C is still across from that angle C. So does that make sense of this and this? We just drew them apart. And they're just the obtuse. This is our right acute angle C, wasn't it? Yeah. And then right here was our obtuse angle C. Okay. Anyways, back to this. Those are all good questions. I'm glad you're asking. That's why we're here. Where are we? Right here. Guys, what's this? Thank you. And then we could find side A and side A using the law of sines. Do I need to continue that? Okay. Okay, awesome. Moving on. Okay, so if you get something like this on the test, let's not make it harder than it needs to be. A person is, I made this problem up. A person is 120 feet away from a snake. And we want to hurry. Don't you want to hurry? Normally I'd say yes, but no. Okay, a person is 120 feet away from a snake on the ground. The snake gets scared and slithers straight up the tree. Now it's up here. The angle, it says of a height of 500 feet. So it slithers up the tree 500 feet. It says, what's the angle of elevation? So when we just set up a trig ratio, opposite and adjacent is tangent, right? We would know how to finish that? Yeah, so tangent of theta is opposite over adjacent. So now how do we solve for theta? Inverse tangent. So theta is equal to tangent inverse of 500 divided by 120. What do we get? 76.5 degrees. That's the angle of elevation. Okay. Okay, this one. Super good that we're going over it. It says use a calculator to evaluate arc sine of 0.45. Now here's the trick. It says find two answers in degrees and in radians. So, couple things to know. Are we all paying attention? So, use your calculator to evaluate. So everybody type in. Arc sine means inverse sine, so second sine. So type it in your calculator of 0.45. Okay, so this is what we've got. Everybody, are you listening? 26.7 degrees. Now remember what arc sine means, right? Arc sine means, I'm going to write it down. What angle has this sine value? Now remember, sine on our calculator and stuff, sine inverse only gives us answers between positive 90 degrees and negative 90 degrees, correct? Okay, so we just got one of the answers to be, the angle is 26.7. So here's 0. I go up 26.7 degrees. I kind of drew that a little bit high, but it's okay. Okay, right? Now that would intersect at an XY point on a circle, right? Isn't sine our Y values? 0.45. It's not a degree. 0.45. Oh, just 0.45. Okay, so now notice it says find two answers, because what this is asking is what angle has that sine value, correct? So think about it. If we go negative x up positive y, negative x positive y, will that have the same sine value? Yep, so that's where our other angle's coming from. So that's up from here, 26.7. So let's do positive angles. So that's called a reference angle, right, everybody? So one of our answers is 26.7 degrees. What is that degree? How'd you get that? 180 minus 26.7, and you got, right? Everybody good? Because sine is y. It says, what's the angle that has this sine value? Yeah, we're about to get there.
Oh, that was the same time.
153 degrees. Okay, so now that's in degrees. Now convert it to radians. How do we convert something from a degree to a radian? Multiply by pi over 180. So multiply by pi over 180. So the radian answer would be for 26.7, 0.47 radians, right? And then the other one would be, type it in your calculator. You'll literally type in pi, 2.7 radians. Okay, let's do another one similar. Here we go. So it says, use a calculator to evaluate cosine inverse, which means the same thing. I'm going to write down, what does this mean? Cosine inverse means the angle whose, or where, cosine is negative 0.35. That's what this is saying, right? Now it says, give two answers in degrees and radians. So type into your calculator cosine inverse of negative 3.5. Negative 0.35. Negative 0.35. Did you all get 110.5 degrees? Now remember that cosine inverse only gives us output between 0 to 180 degrees. Let's draw in 110.5. So that would be going around somewhere over here, right? 90, 110. So I'm going to draw that in. So that was some XY point here. And that was 110.5 degrees. Okay, that is true. Now, also, it says give two answers. Well, that's because, oh, this is negative xy, right? Cosine is x, right? Won't a point down here also be a same negative x, negative y? Right? So won't that have the same cosine value? This. So that would be, well, let's figure out what that is. So 180 minus 110.5, right? Yeah. So this is 69.5. So this is down 69.5. Won't that put us in the same spot as this XY point, right? So then, what positive angle is that? You'll take 110.5, nope, 180, right? Plus 69.5. Or you can do it 360 minus, what? 249. Oh, and I think it might, yeah, okay, 249.5 degrees. And now you could convert that to radians, multiply by pi over 180. So just make sure that you understand how to do that. You'll literally just type that into your calculator. That times pi, hit enter, divided by 180. It's going to be 1.9 radians for this. So I don't know if that's considered wax or not.
Yeah.
And then this one is 4.3 radians. Because remember, 3.14 radians is halfway around the circle. So we're just writing it in degrees and this is in radians. Does that make sense? Remember, there's just over 6 pi, or over 2 pi radians, which is around 6.2 radians on a whole circle. Does that make sense, everybody? Yeah. Okay. Okay. Find the area of a triangle with these. Oh, it's given us 3 sides. So you would draw in a picture, label it correctly. ABC is what I do first. Then I put side A across from side A. Side B across from side angle B, and side C across from angle C. You see how I drew that correctly? You gotta draw it correctly. So area of any triangle is 1/2 times side 1 times side, times side 2 times by sine of the angle between, if you want to use that formula. So to find the angle in between our obtuse angle, we would find our obtuse angle, we would use the law of cosines, right? If we were going to do it this way. How many of you liked Heron's formula?
I do.
Cool, let's go for that then. So given 3 sides, we can use Heron's formula. The first thing is to find S. So that would be A plus B plus C divided by 2. That's the formula for S. So 3 plus 2 plus 5 divided by 2 Okay? Then Heron's formula is this. The square root of that 5 times 5 minus 3, which is times 5 minus 2 times 5 minus 5. Are you sure that's 5? 5 plus 2 is 10. 10 plus 3 is, what the heck? 5 plus 2 is 10. 5, 6, 7, 8, 9, 10 divided by 2 is 5. What the heck? Well, here's the thing. That'll give us 0 the area. I made this problem up on the fly. That's what it is. Amelia, you're right. This triangle just doesn't really work. It doesn't exist. That's what it is. Like I said, I just put 3, 2, and 5 and didn't even think about it. Does that make sense, everybody? So normally, if this wasn't 5, this triangle doesn't exist. You guys get what I'm saying, right? That's not going to happen on the test. Like I said, I made it up on the fly and didn't think about the fact that that triangle didn't really exist. Yeah, well, the thing is we could just make it whatever, but I really wanted it to just come out kind of nice and pretty, but. Okay, are we good with that? Do I need to really come up with one? Are we good? Because like, why spend extra time if we all get it? Okay. Cool. Okay, find the area of the triangle. So this one's easy. We're given, you have to label it right. ABC, angle B is 25, side A is 10, side C is 15. Oh, this one's nice, right? We're given 2 sides and an angle. This is perfect situation. That's almost too easy. I should make it harder. 1/2 times 15 times 10 times sine of 25. It's that easy, right? So our area for that would have been whatever. Type that in for me. 31? Was that our one spell? So it says, what is the measure of angle ABC? So which angle is that really? ABC is angle B, right? So then, won't we have to use the log cosines? So outskirts of town, right? That's what you put in solving the log cosines, I say. So we're going to have cosine of B on the outside, so we need side B on the outside. 15 squared equals 10 squared plus 11 squared minus 2 times 10 times 11 times cosine of angle B. Now you just use algebra to solve for B. Okay, I didn't do that one. So we would get, I'm waiting for you guys to calculate it because I don't have the words already out for you. $91? Perfect. So then we're done with that one. Does everybody see how really, if you know what you're doing, you should be able to know what you're doing for the most part so far? Okay. So we're just making sure you practice extra. Okay. So we're graphing this. So we're gonna go really slow and remind you of a couple of things, but really, I know you can do it. So first of all, it looks intimidating right now because there's so much going on. So you've got to think of it in sections. So it is going to ask for these specific things. So first of all, anytime we see secant, we're going to rewrite it as cosine. So rewrite it as 2 cosine of 3x minus pi plus 1. And let's go through and answer these questions before we start graphing. So our amplitude is 2. Our period, which means length of one cycle. So you have to remember that because that's going to be used a lot. Length of one cycle, and we're going to draw in 2 cycles. So our physical length of one cycle is, for cosine, is 2 pi divided by b. Now remember, b is what's in front of x. So 2 pi divided by 3, 2 pi thirds. So the length from the start to the end of one cycle will be a length of 2 pi thirds. Okay? Now, a phase shift is just left and right. Where's it shifting? So remember, normally cosine starts at 0, correct, everybody? So if we're shifting it, so we're going to set the inside here. set 3x minus pi equal to 0 and solve for x. 3x minus pi equal to 0. Solve for x to see where now our x is. It used to be a 0. So we would add pi, right? 3x equals pi divided by 3. So x equals pi thirds. So it used to be 0, it's now pi thirds. Isn't that a shift of right pi thirds? E. So this is what we call a phase shift, okay? And then our vertical shift is up 1. Okay, so let's go over here and draw in a couple things. So first of all, if there's a vertical shift of up 1, it still starts at 0. It's just at the top.
Oh, you're right.
Does that make sense?
Yeah.
Okay. Good question. So first of all, our vertical shift is up 1. So let's start there. I'm going to give myself 20. I'm going to spread this out. I'm going to call that 1. Now our amplitude is 2 from there. So I'm going to draw in. So we're going up 2 more, correct? Puts me at 3, right? Because that's our midline. And then down 1, 2. So amplitude for midline, so that'll be at -1. And I kind of like to have something drawn in, so I know exactly where to go, how high up and down to go. There's going to be a lot going on with this graph. Now also it's kind of nice to draw in since we're up 1. This is our new midline. Does everybody see my new x-axis? Okay, then also we're shifting. So we're shifting, that's where we're going to start next, right pi thirds. So instead of starting at 0, we're shifting right pi thirds. So that's where we're going to start, draw in your new y-axis. It's going to take studying. There's no other way to put it. Here's y-x. I know there's a lot going on. This one's the worst one. Okay, so now we have to know the length of one cycle. So now we're starting here, right? Here, call this our new origin, right, everybody? So our length of one cycle is 2 pi thirds. So remember, cosine, it starts at the max, 0, min, 0, max. So there's 4 tick marks from our starting point, right? So go to your starting point. I'm going to go down to the real x-axis to put in the tick marks. So we're starting here. We're going over 1, 2, 3, 4. There's one cycle. Now that physical length is 2 pi thirds. So you'll take 1 pi thirds and add 2 pi thirds because that full distance is 2 pi thirds. Does everybody understand? So that puts me at pi. Take your calculator and do, or just think about it. 2 pi thirds plus 1 pi thirds is 3 pi thirds, which is pi. Does everybody agree? Now we'll go over 1, 2, 3, 4 tick marks. We do have to draw in 2 cycles. And that's another 2 pi thirds units. So you'll take pi, so 1 plus 2 thirds, right? To put me at the right spot. So then you'll do it and you get 5 pi thirds. So now we'll fill in more on the x-axis. Let's find the halfway distance between these 2 points. So how do we do that? We add 1/3 plus 1 divided by 2, right? Does that make sense? We're finding that distance and then dividing it by 2. So this right here in the middle is 2 pi thirds. Now you'll do that here. 1 plus 5 pi thirds and then divide it by 2. And you can just do it in your calculator, like get a common denominator, you know what I mean? So it's 4 pi thirds.
What was the one in the middle of that?
2 pi thirds. But do we know how to use our like, do you get what we're doing?
Yeah.
Okay, just making sure, because I could explain it, but I just thought we did.
I know.
Like, guys, we're just doing like, we're going like this. So, like, I want to know the distance between those points.
Yeah.
Which is
Pi plus 5 pi thirds divided by 2. We are going to just use our calculator, but we can't type pi into our calculator. 1 plus 5 thirds. In your calculator, because we don't want to have to think more than we need. What do you get?
Oh, yeah.
And then you divide it by 2 to get us the halfway distance. So isn't that 4 thirds? So that's why I put 4 pi thirds. Okay, that's good enough. Now let's draw in cosine. So we have to go to our new origin, which is right here, right? New origin. And then cosine starts at the top, the max. So at the first point, it's at the max. At the next point, it's at the, oh, and here is my, oh, yeah, sorry, midline. Sorry, there is a lot going on here. Okay, so at this point, we're at the midline, right? Then at this point, we're at the bottom of our amplitude. Then at this point, we're at the 0, which is up here now. And then at this point, we're at the max. So I'm just drawing in because it's not really there. And then at this point, the 0. At this point, the bottom of the amplitude. At this point, the 0. And at this point, the top. Yep, cosine looks like a C, right? No. But you could think of it like that. Because it does kind of look like that
How
too.
the heck is that?
A C on its side. Remember I said you had to squint your eye, look sideways, and close the other. Oh, I see a C there. Okay. Okay. Then here's the next thing to think about. This isn't really cosine that we're graphing. We're graphing secant, which is 1 over cosine. So cosine cannot be 0, right? So when is this cosine function 0? When it crosses the real x-axis. That's what was tricky about this one. This one was really advanced. Look at this cosine function. If I said, what's the function at this point? You'd say 1. If I said, what's the function right here? You'd say 0. That's a problem. We can't have our cosine 0 because we can't divide by 0. So our vertical asymptotes are wherever it crosses the x-axis, the real x-axis that is. This one was a nightmare. And now we can finally draw it in. So smiles become frowns. So this goes up like this. This goes up like this and like this. This. My hills are still there. Look, cosine was just red dots.
I have a question.
Here was this down.
Like, you know, I was thinking for class,
The cosine equals 0. Yeah. When,
is that the middle?
no, that's why we had to look at the real x-axis. Because like I said, even though we graphed this, if I said to you, what's my function for when is cosine 0? That's right there, right? Look, these are the y values. Does that make sense, everybody? So this one was the most advanced.
So the only reason we draw a little x and y
To make it easier to graph. No. So that was a lot going on. Okay, next example, guys. We're going way too slow. Here we go. So, amplitude is 2. My period for tangent is different than sine and cosine. Remember, period normally is just pi for a non-shifted tangent, right? So then this is pi divided by b. So pi divided by b is in front of x. Pi divided by 3 pi halves, which is 2/3. If you needed to go off to the side and do the algebra more elaborately, that's what I had to do to get it right. Did I do that right? Yep. Okay. Does everybody go 2/3? And then our phase shift. Is there any shift left or right? So none. This one's nice because there's no phase shift. And our vertical shift is none. Right? So normally our asymptotes for our tangent are like, remember, so our period, since our period for tangent normally is pi, remember it was split evenly here for a non-shifted between negative pi halves and pi halves, right? So now that's 2/3 is got to be split evenly, 2/3, and we're going to have asymptotes like this. So what value will this asymptote be at? Negative 1/3, right? Cut it in half. And positive 1/3. And then we'll go over another 2/3. And then how would I figure out what that's at? 2/3 plus 1/3. Yep, you're right. It's at 1. Maybe I should write that in a different. We can keep going. A shift left and right. That's probably enough because that's 2 cycles, right? So let's just do the least possible. So then remember, our amplitude's up 2, so we're going to draw up 2, down 2, so 2 and negative 2. And then remember, tangent is increasing, right? Increasing. And then remember, halfway between is where it hits at the zeros. So what point will those points be? 0, and then 1 plus 1/3 divided by 2, right, guys? So then from there, I'll graph tangent in pink. Halfway between, it hits at the zeros, right? And then over this way, it will go up to the max, to be increasing over this way down to the min. And now we drew in that tangent, ding, ding. The detail I'm showing here is what would be expected. Tangent's a special period. Tangent period is pi, normally. So to find a shifted tangent, or like one that's been, like, you know what I mean, has a transformation, you would take, instead of 2 pi divided by b, we're taking pi divided by b. Isn't b always what's in front of x? So that's why I took pi divided by my b value. Gotcha. Everybody good with that one? An easier one. Okay, next one. Cotangent. Here we go. So we would rewrite cotangent. Well, cotangent's the same as tangent, but decreasing. So my amplitude's 2. Period would be pi divided by b, which b is 1/4, right? So our period is 4 pi. Our phase shift, there's none. No shift left and right. Our vertical shift is none. So then from there, our full cycle is 4 pi. It's got to be split evenly. Nope, I wrote that wrong already. Because I started to go fast. Here's the thing. With cotangent, remember that they're not like tangent. The asymptotes aren't split evenly. Cotangents start at 0. Now, why is that? Does anybody, do you want me to go back and explain that real quick or remind you? So why is tangent's original asymptotes at negative pi halves and pi halves? I'll tell you why. I'll remind you. Tangent is cosine over sine, right? Nope, it's not. It's sine over cosine. Sine over cosine. So think of the unit circle. This is point over 0 up 1, right? This is over 0 down 1. This is over 1 up 0, and this is over negative 1, 0. We know that we can't divide by 0. So when is the cosine 0? At positive pi halves and at negative pi halves. So that's why tangent's original asymptotes are at negative pi halves and pi halves. So let's do cotangent. So we have to think about cotangent. Cotangent is actually cosine over sine, the reciprocal of tangent. So cosine over sine. So we know that sine can't be 0, right? So on your XY chart again, when is the, because remember, I'm going to write this out. Yeah, 0 and pi. Because remember, sine is y, right? So our asymptotes for original cotangent is 0 and pi. Does that make sense? So now our period is 4 pi. So we're going to start at 0, but instead of going over to pi, it's now over to 4 pi, right? Isn't the length of a cycle between 2 asymptotes? So from there to there is 4 pi. So then where will this put me? 8 pi, 4 pi. So let's do one over here in the negative. Where's that going to be? Negative 4 pi, right? Okay. Yes. we go halfway between, that'll be 2 pi. Halfway between that is 6 pi. Halfway between that is negative 2 pi. That's what I'd want to see listed. Now the only difference is, so our amplitude's 2, equal negative 2, and now the only difference is cotangent is decreasing. So in between will be our zeros, and then it's decreasing. So over here up to our amplitude, over here down our amplitude. There wasn't a shift left or right, right? What? Yeah. Actually this one's good. This is a lot. Okay, so last graphing one, here we go. Our amplitude is 1. Don't say negative 1 on the test. Yeah.
So the period like all four. Like how big is it?
So, like right here is 4 pi units, right?
So then there would be like pi, 2 pi.
So yeah, look down here. From here to here was 4 pi, right? Yeah. 8 pi.
Like the 4 pi.
Yes. But this actually, yeah. Okay, so our amplitude 1, our period for sine is 2 pi divided by b, which is pi halves. So that would simplify to be 4. Okay, then our phase shift is none. There's no shift left and right. Our vertical shift is down 2. Do I need to even continue this one? If you guys are comfortable with sine and stuff, then I won't waste time. Okay, so we start with our down 2 part, right? Because that's our x-axis transferring down here. So I'm going to draw that in. New x-axis, that's at negative 2. Our amplitude's 1, so I'm going to spread that out a little bit better just because I want to actually be able to draw a graph and not have it all scrunched. So down 1, 2. Does that help? So negative 2, there's our new x-axis. Here's our amplitude, right, at negative 1 and negative 3. Why? Because it's an amplitude of 1, right? Okay, now was there a shift left or right? No. So luckily we get to just start. So our period, the length of one full cycle is 4. So starting at 0, we're going to go over 1, 2, 3, 4 and put a 4. Over 1, 2, 3, 4 and put a 8. So then that's 1, 2, 3, 4, 5, 6, 7, 8. Mm, 80% of the tick marks need to be labeled. The more labeling, the better. If you only label like barely any, I'm going to mark it wrong. Well, I'm just going to dot points. Okay. So then, our amplitude, is a reflection over the x-axis. So normally sine starts at the 0, max, 0, min, 0, right? So it's still going to start at 0. Then it's going to go to the min at that point. At that point, it will be back to the 0. At that point, it will be at the max. At that point, the 0. At that point, the min. At that point, the 0. At that point, the max. At that point, the 0. Pretty good, right? Okay, last thing to finish this up. So, next thing, it says evaluate. This is where you'll use your unit circle to give exact answers if possible. I haven't decided yet.
Wait, we get one.
I haven't decided yet, but you can still fill one out, right? If I decide to have you fill one out. Well, of course it will help. You've got to be able to fill out a unit circle. I have not decided yet. I'm going to go through and do the test, and if it takes too much time to fill out a unit circle, I might give one. If not, then I would rather you fill it out. I'm going to do it though, and then I'll know. Not your opinion. Arc sine of 3 pi fourths. So we work this from the inside out. So sine is 3 pi fourths. You do unit circle. Sine is what? Y, guys? So that is square root of 2 over 2, right? Now arc sine means the angle whose sine is that. Remember, our outputs for sine are between positive 90 degrees and negative 90 degrees for inverse sine. So where is the sine value that same thing? Pi fourths, right? That one should be really straightforward. Pi fourths or 45 degrees. I'll say on the test if I care. If I don't say, just put both. But I think I do say in radians or in degrees. Okay, arc cosine of cosine of 7 pi 6. So you'll find 7 pi 6 cosine is x. That's negative root 3 over 2. So now it says the angle whose cosine is that. So remember that cosines are outputs, our arc cosines outputs are between 0 and 180 degrees. So you gotta look up here only. And you're looking here only on that one. So that is 5 pi 6 or 150 degrees. Yeah. Negative 30. Because that 330 isn't in the domain. Does that make sense? Good question. So I just got asked a really good question, and I hope a lot of you heard it, which I know no one heard it. So if we had this as an answer, would we put for sine inverse that angle, or would we put that angle? We have to put that angle, the negative that angle. Does that make sense? Because that angle is not in the domain. Okay. Okay. Find the exact value of secant of sine inverse of 15 over 17. So look from the inside out. Isn't this just, we have an angle whose sine value is that? That's what sine inverse means, right? So opposite over hypotenuse. Draw a right triangle, because that's not on our unit circle. Put in a theta. Opposite hypotenuse is 17. So then we would do a Pythagorean theorem, right? What do we get? Eight? Okay. So now it says find the secant of that. Sine inverse means the angle has this sine value. That's what inverse sine means, right? I feel like you didn't learn anything this unit. I'm sad because I feel like I taught you this. Secant is what ratio? So secant is the reciprocal of cosine. Cosine is, oh heck, another hour. So hour over adjacent, right? Well, this just means we haven't, like that's what we've been talking about when dealing with inverses. We rewrite it as we have an angle whose sine is that. So we have an angle whose sine value is 15 over 17. Yeah. Other people got that, right? Just making sure, because like we talked about that a whole day and a whole lesson. I'm just making sure that like, have you been doing the homework? Okay. Okay, then we should be good with those. So then secant of theta equals hypotenuse over adjacent, right? You're right. Okay, where do I need to start? But if I'm going to start over, then you need to not talk when I'm teaching, because these are the only people that are actually listening. Do you want me to just stop? Are you guys good? I'm not getting mad at you guys, like I said. Okay, what's the question? Okay, so secant of theta theta is the reciprocal of cosine. Cosine is, so then that means secant is hypotenuse over adjacent. So I have this triangle that was drawn from that. So secant is adjacent over hypotenuse. So that's 8 over 17. Sorry, I can't think because everybody is thrown me for a little bit of a loop today. Okay, any questions on that? Okay, sweet. Do you want me to go over this last one or no? Okay. So, it says sine of arc cosine of 1 over x plus 2. What does arc cosine mean for people that are ready to go with that? What does arc cosine really mean? What is the angle who has this cosine value, right? So, we have a right triangle. We have an angle. The cosine is adjacent over hypotenuse. We have an angle who has this cosine value. Adjacent is 1. Hypotenuse is x plus 2. So let's do some algebra to figure out this side. So it'll be x plus 2 squared minus 1 squared equals, let's not call it x. Question mark squared. So now solve for question mark, right? Square root both sides. So question mark is equal to the square root of x plus 2 squared minus 1. Can I just square root cancel out with square? No. Okay, good. Good job. So we have our x plus 2 squared minus 1. So now we can answer sine. So it says sine of that. What's the sine of that? Sine of that. Sine is opposite over hypotenuse. So sine is equal to square root of x plus 2 squared minus 1 over x plus 2. Okay. These are the review problems. It looks like more than it is. It's around 35 problems, roughly.